This is the third video for section 2.1 about functions. In this video, I'm going to talk about something called the difference quotient. The difference quotient looks like this. F of x plus h minus f of x all over h, where h cannot equal 0. What is this weird thing? Well, I'm not going to tell. But it's extremely important to be able to simplify in calculus. They'll teach you all about the difference quotient and how it's really important. What I'm going to do is do a tricky one for you, because it's really important that you go to calculus understanding how to simplify the difference quotient. Okay? So my example is that we're going to find the difference quotient of f of x equals 1 over x plus 2. Okay? So notice we need to find two things to plug into the difference quotient. F of x plus h, and then of course f of x, which we already know. F of x plus h means take x plus h and plug it in everywhere that you see x. So our original equation was 1 over x plus 2, so now we have 1 over x plus h plus 2. And of course we know the second piece of the difference quotient in the numerator is just plain old f of x. The denominator is h. So now we're going to plug them in. We can say that f of x plus h minus f of x all over h is equal to 1 over x plus h plus 2 minus 1 over x plus 2 all over h, where h is not equal to 0. Now we have the fun task of simplifying. In the numerator we have two fractions. We want to try to combine them using a common denominator. But a little trick that we can do, instead of actually combining them, is if we find the LCD of those two denominators, we can actually multiply our entire fraction, including the h on the bottom, times that LCD on the top and the bottom. Remember, if you multiply a fraction by something on the top and the same thing on the bottom, that fraction keeps its value, because what you're multiplying by is really equal to 1. Alright, so now if we find the LCD of the two denominators we have, we see that it's x plus h plus 2 times x plus 2. Remember that an LCD is something that both denominators can become by multiplication. So it wouldn't be enough to use x plus h plus 2, because x plus 2 can't become x plus h plus 2 by multiplication, only addition. So when that happens, we need to use the entirety of both denominators. Now what we're going to do is we're going to multiply the entire difference quotient by the LCD over the LCD, which is equal to 1 whole. So we're going to multiply x plus h plus 2 times x plus 2 all over x plus h plus 2 times x plus 2 times our difference quotient. Never multiply these out. Don't multiply this trinomial times this binomial or any other thing that you would in this process, because we're going to need it in factored form. Okay, so I'm going to take my LCD over my LCD, x plus h plus 2 times x plus 2 all over x plus h plus 2, times x plus 2, which is equal to 1 whole. And I'm going to multiply it by 1 over x plus h plus 2 minus 1 over x plus 2 all over h. Because I'm multiplying one factor, or two factors here, times a term, two terms in this numerator over, in this numerator here, I've got two factors being multiplied by two terms. The factor is going to get distributed to both of these terms. Okay, so I'm going to rewrite this multiplication like this. I'm going to write a big fraction bar. X plus h plus 2 times x plus 2 first gets multiplied by 1 over x plus h plus 2. Then it is distributed, x plus h plus 2 times x plus 2, to be multiplied by 1 over x plus 2. Now notice our denominator is going to be x plus h plus 2 times x plus 2 all times h. In the numerator, in this first term, when I multiply x plus h plus 2 times x plus 2 here, the x plus h plus 2 on the top and the x plus h plus 2 on the bottom cancel. I'm going to squeeze this in here. Remember, we could make this a fraction over 1 and a fraction over 1. So I'm just multiplying numerators and denominators. And when I do that, the factor x plus h plus 2 cancels. So all I'm left with in this term then is x plus 2 times 1, which is x plus 2. In the second term here, x plus 2 in the numerator and x plus 2 in the denominator cancel, and all I'm left with is x plus h plus 2 times 1, or just x plus h plus 2. Notice in the denominator, I still have x plus h plus 2 times x plus 2 all over h. Be careful not to cancel x plus 2's now or x plus h plus 2's now, because they are not factors in the numerator, they are terms. What we need to do is distribute the negative in between the two terms. So we get minus x minus h minus 2 all over x plus h plus 2 times x plus 2 times h. And then we can combine like terms. X minus x cancel, 2 minus 2 cancel, and we're left with minus h over x plus h plus 2 times x plus 2 times h. But it turns out now this h is a factor. And what we're left with when we cancel that factor in the numerator is a negative 1. And in the denominator is our LCD, x plus h plus 2 times x plus 2. There's no need to multiply the denominator out for our final answer.